Hey everybody, before we get started, just a really quick announcement. Our good friend Matt Cat Music has opened up enrollment for his Programming for Musicians course. So due to the success of the last course that he did on teaching C++ for musicians, he's decided to open up enrollment again for another 6 weeks starting on Saturday. So there are only 3 days left to order, and you can save 15% with the discount code, the audio programmer. Just use that code on checkout to enroll. Be sure to go to theaudioprogrammer.com to sign up. And another quick reminder, if you're not signed up to our audio programming community on Discord, be sure to come check us out. So we have audio programmers from around the world, all different levels, everybody from professional developers at places like Rolly, Native Instruments, Ableton, and so on, all the way down to teenagers that are just typing their first lines of code, and everything in between. And we're all discussing different questions around audio programming. So it's a community for everybody. And if you're not there yet, I'd love to see you there. So be sure to check us out and be sure to sign up if you're interested for Programming for Musicians on theaudioprogrammer.com. Hey, what's up everybody? I'd like to welcome you to another Juce tutorial. And in this tutorial, what we're going to do is take things back to the basics and start doing a few of the beginner Juce tutorials for people that are just getting started with Juce. And one of the most common questions that we get in the Discord chat is about painting graphics to the screen. We get a lot of people that say, hey, I've drawn something in my paint function, but the thing is supposed to move, but it's not moving. What's happening? And the reason that that's not happening is because people haven't called Repaint, and in order to call Repaint, you have to use a timer that calls Repaint time and time again. And that's what we're going to talk about for this tutorial. We're going to build a very simple project that's going to have a ball that's going to just kind of go across the screen. And so the ball is going to be in motion. And then I'm going to show you some basic concepts around how to actually repaint the ball so that it continuously kind of paints and draws in another component. So we're going to create another project here. So this is just going to be a regular audio application. Same kind of concepts apply for if you're building a plugin. So I'll call this timer component. And after I'm done, I'll upload this on my GitHub so you can check it out and experiment on your own if you'd like. So we're going to hit create, and then what we'll do is we will just open this in our IDE, and here we are in Xcode. And so let's just go ahead and open quickly the Juce API. So you could do that through juce.com/doc/classes, and this will take you to our API. And so the class that we're going to use here is called the timer class. So if we scroll down here, we will see the timer class, and it says makes repeated callbacks to a virtual method at a specified time interval. Okay, so what it means by virtual method what that means is that we don't actually have to create an object of timer. Okay, we don't actually have to create a timer object in order to be able to use this. The timer is already kind of there virtually, and we can call the timer to start or to stop. Okay, and I'm going to show you exactly how to do that. So if you're like me, coming from a background of kind of processing or P5JS, where you have kind of a void setup and a void draw type of workflow, where you have one function that kind of happens once when you initially set up your app or your creation, and then you have another function that's called void draw, where it continuously kind of repaints in the background. Okay, and then if you're moving to Juce, you might say to yourself, well, where's void draw? right? And this is kind of the same sort of concept, something that kind of continuously calls in the background. Okay, so I'm going to show you how to do this. So like I said, it's a pure virtual method. So what that means is that we don't actually have to create a timer object. We can just actually call it. But we will see here that we have this virtual void timer callback, and then we have this equals 0. And what that means is that if we inherit from this class, then what we need to do is we need to actually implement this function in order for the in order for our project to compile, or else it will not compile. Okay, and I will show you that really quick. So here we are in our main component header file. And so the first thing that we want to do is we want to inherit the timer class. So what we're doing is we actually want to say, hey, in this main component class, now I want to bring in this timer functionality so that I can call on this. And that's exactly what we're doing here. So what we'll do is we'll just make this public, and then we're just calling it the class. As we can see here, we got this class here that's just called timer, and that's exactly what we've put there. Okay. So now, and when it goes green, that's a good sign that we've done something right. So and so, like I said, this is a virtual method, so we don't want to do something like this, where we create an object of timer, of timer, right? We don't want to do that because it's a pure, it's a virtual class. So what we could do is we can go back to our API here, and then if we scroll down here, like I said, we have to implement this virtual method called timer callback. And so what we'll do is we'll just put this here. So what that means is that we have to create this method called timer callback within this class. And since this is a pure virtual function, we want to use the override keyword, and the override keyword just lets readers of the code know that this timer callback is a pure virtual function that we're calling from one of the classes that we're inheriting from. Okay, so now we need to implement that. So we've declared it, now we need to implement it. And if we just scroll down here, and I will do void, and then this is our class main component, and then the method is called timer callback. And now I've just implemented it there. And now we will just compile this just to make sure that this actually compiles. And now we have just a blank screen. There's nothing in there. So now what we want to do is we want to do something with this timer callback. So now if we go back to our documentation here, and we look at our methods, so we have a timer callback. It's going to get called back periodically. So it's going to be called periodically, and we need to actually tell it how often we want it to call. So a typical time for something like this would just be something like 60 hertz. Okay, it just means that it calls 60 times a second. So you might ask yourself, okay, with this virtual method, if I don't have a timer object, how do I actually call it? So the way that we do it is we can just go here into our main component constructor. So the constructor is what calls when our app is first set up. So this only calls once, kind of like void setup, so to speak. And so the way we do this, if it's a virtual method, is we actually just call the class, and then we use the scope operator, I believe it's called. And then we want start timer in hertz. And here I will just put how often I want it to call every second, so 60 times a second. Okay, so now the timer is started, and then we have the destructor. We know it's a destructor because we have this little tilde object here that says this is what happens when the main component actually destroys. And what we want to do is we want to stop the timer. Stop timer. Okay. So that's one of the things that we want to do when the app is shutting down. We want to say, hey, stop the timer. So, so now we have this, and now we want to create something. Let's just make another component where we have a ball that goes across the screen. When it gets to the end of the screen, it bounces back. So what we need to do is we need to create another component class. Okay, so we will exit out of Xcode and just minimize this for now. And then in our producer, we will just hit this little plus button down here under the File Explorer. And then we have this add new component class split between a CPP and header. Right, and I will call this, I'll just call it ball. And I always do this where I save it outside of the source folder, but just drag them in there. So now we have our ball.cpp and ball.h, and now we open Xcode again. And so now we want to go ahead and start creating our ball. So as we can see, this is a component class. So the component class just means that it's a rectangle essentially that's drawn on the screen. So you can have a slider within your component, you could have a dial, you could have a ball bouncing somewhere. Whatever you want to draw within this component, you could draw it. And then what we would do, since ball is a child component of the main component, then we can draw this ball component as big or as small as we want to, right? And I will show you how that works. So we have this void paint function here. So this is what happens. This is what actually draws our graphics to the screen. So I'm just going to just take all of this, I'm just going to delete it. And then first thing that we're going to do is we're just going to paint the background. We'll paint the background black, right? So what we could do is we have, if we want to look at what can we actually call in this paint method, then what we could do is we can go back to our Juce API here, and we can actually go to the graphics class, which is right here at the top. Okay, and so I'm going through this quite slow just to show people a little bit how to read the actual documentation of the Juce API, and just how to kind of make sense of what they're seeing in the Juce framework. So we see that we have a Juce, that we have a graphics object. We know it's a graphics object because it has a capital G. So this is a reference to a graphics object, and so we can basically call g.setColor, g.setOpacity, so on and so forth. So I'm going to use one that's called fill all. So if I go here, then I see that I have this fill all function here that I can call, and then in here I can put a color. So let's say that I don't know what color, how to actually declare this. So what I could do is I can actually just open that up in a separate tab there, like that, and then we have the color class, and then it says I can actually call a color, and you have loads of colors. I'm not going to go through all this, but you can use RGB, you can use HSB if you want to, or you can use one of the kind of built-in colors, and that's what we're going to do here. So once again, we go g.fillAll, and then now I have a color, and I could go colors. It's actually colors, and then what I could do is I could just call one of these colors here. So there's loads, and I'm just going to call it black. So if I command click in here in colors, you will see that it has a list of all the colors that we could actually call. So you can make it light salmon, you can make it goldenrod yellow if you want to, loads of different colors in there. Okay, so, but for now, we're just going to make it black. So now what we want to do is we want to make a ball or a sphere or an ellipse. So Luckily, the Juce class, graphics class, has a function for that. So if we go to Ellipse, so we see that we can call this a couple different ways. We can call it using an X and Y position, and then how wide and how tall we want the ellipse to be. We could use a rectangle object. Okay, we can do the XY width height thing along with line thickness if we want to, and then we can do another rectangle with the line thickness. So let's just try this. So the float X and Y is just a starting X and Y position, and then the width and the height, pretty self-explanatory. But let's just try it. Let's just try using this draw ellipse using the rectangle object here inside here, because I want to show you this, because this is a little bit this is very useful to use here in Juice, the rectangle object. Okay, so what I could do is I could declare a rectangle object, and this just literally draws a rectangle. Okay, and rectangle, and this is going to be of type float, and we will just call this area. And then what I could do is, if I look into the rectangle class, so you see how I'm just going into a class, and then we see that we have parameters that we got to fill in, so then we got to go into another class and see what we need to do to actually create that object, right? So we need to create a rectangle object. So here we have initial X, initial Y, and then width and height. So what we could do is we could just initialize this rectangle object that we've just created called area by just using initial X. So I'll put it at 10 and 10, and I will make the ellipse, let's just say 20 by 20 pixels by 20 pixels, right? So now I've just created this rectangle object, and now I want to go back to my ellipse, and and essentially what it does is it creates a rectangle, and then you can't actually see the rectangle itself, but the circle is within the rectangle. So the rectangle is just defining the area of the circle, so to speak. So I could do g.draw ellipse, and now we see that we have this rectangle object that we can put in here. So I could just call this area, and then line thickness, let's just say 2.0 for now. And so now we've drawn an ellipse, but there's another problem actually. Now that I think of it, the problem is that the ellipse that we've drawn, so we've selected, we haven't told it what color that we want the ellipse to be. So let's just go ahead and draw and set the color. So we could use that. We could do that using set color, and then we could do colors. Let's do like goldenrod yellow, right? So now we've set this. So now we've set the color to like goldenrod yellow, and now we've drawn the circle. So now we've got this ball class where we've drawn a ball. But now what we need to do is we need to actually get this to draw in our main component, because if we compile here, we will see that there's nothing there, even though we've drawn a yellow ball. So why not? And the reason is because we have to now declare the ball class. We now have to create a ball object within our main component. So our main component is kind of like our processing center where everything kind of feeds into. So it's kind of the root of our tree, so to speak. So first thing that it needs to do is it needs to know about our ball header file. So the first thing that we need to do is we need to actually use include. So we got hashtag include, and then ball.h. So now we've actually got the functionality for for our ball object that we've just created. And now we can just call this by saying ball, right? So now we're just creating an instance of the ball. Now if we go into our main component, what we can do, so I'm just going to get rid of all this because we don't actually need it. And I'm going to get rid of all this code, all these comments and stuff. So now what we can do is we need to add it as a child component to our main component. So we're basically saying, hey, main component, you now have a child component that called ball, okay? And we want to add and make it visible. And then I could just put ball in there, okay? But then we compile it, right? And we will see that we still see nothing, right? We don't see anything. The reason that we don't see anything is because we haven't told the ball object how large we want it to be, okay? And we can do that down here in resized, okay? So resized gets called when the main component first gets created, and then anytime that the component is actually resized. Okay, so what we could do is we could do ball.setBounds, and then here let's just say that we want it to be get the width of the component that we're in minus 100. And then we could do get the height minus 100. And then we'll make this 200 by 200. So that'll be the size of our whole component, not the size of the ball itself, the size of the whole component. So, and then what I could do is I can just go into the paint method of the main component. I can erase this. I can do g.fillAll. And we'll make this colors white. So now what we should see is we should see a white screen with a black square in the middle with a yellow circle. Okay, so we see the white screen. Oh, I meant to call this get width divided by 2. My bad, but we see that it's over here in the right hand corner. So what I could do is I could just go back here and I could do get width divided by 2, get height divided by 2, and that should put it in the middle of the screen. Okay, and so now we see the circle, and now this is in the middle of our component. And as we see here, we can make this any size that we want, right? So I could, if I just cut this out for a second, I could actually say get local bounds, which gets the width and the height of the parent component, which is our main component, right? So what we should see now is an all black screen with a yellow with a yellow ball, like so. So now we see that, so the main component, the white background is here, it's just beneath this black canvas here. So we've actually painted this over top of our white canvas. Okay, so now we have this, I'm going to change this back, and we can, like, just to make it, just to kind of send the point home here, I could put this at the origin, and I can make this 300 by 300 if I wanted to, and it'll put it in the left hand corner, okay, which is our origin, and make it 300 300. So we can really make this any size and configuration that we want, okay, but I will just put it in the middle of the screen. So now what we need to do is we need to think about moving this ball, right? So if we go back to our ball.h, then, or our ball.cpp rather, we'll see that we have this rectangle object where we've set some initial coordinates. So what we need to do is we need to actually we need to actually move this now. So where this X and Y coordinate is changing. So what happens is that it's kind of like drawing a cartoon where every time that we call the repaint method, so every time we call repaint on this ball component, then it should draw our ball in a new place. Okay, so let's just give that a try here. So let's think about this for a second. So one thing that is interesting that I was talking with Chris Randall from Audio Damage a little bit earlier, and he's one of the leading UI designers in music tech. And he actually looked at this Twitter post that I made earlier, and he pointed out that I had actually drawn all this stuff in my paint method, and that I should actually be making the changes to where the ball is in the timer callback in the main component. The reason is that if I was using a plugin, then what would happen is that when you actually close, so you know, when you have a plugin, you pull up the graphical display and you can actually see the graphics. And what happens is that when you actually close that down in a plugin, that actually destroys that component, I believe. So what happens is that anything that's happening in the paint method of ball or in your editor, if you're working in a plugin, would actually not be happening anymore because it's not there anymore. So what you want to do is you actually want that to be happening in your processor if you're using a plugin, or in your main component if you're using an audio app like I'm using. So that ensures that any changes that are happening are still happening even when the UI is actually closed. Okay, so that's the reason why we're going to do this a little bit more complicated. So I'll do it this initial way, and then we will actually change it over, because I want to start it off simple. So what we'll do is we'll make a int. We will call it pos x, and we will initialize it with a value of 10, and then we'll do a pos y, and we will make that 10, because that. And then what we could do is we could do pos x and pos y. So I've just made variables there that have replaced the numbers. Okay, so we will see here that it complains here because it's saying cannot be narrowed from type int to float in the initializer list. The reason that that's the case is because we made a rectangle of type float, not a rectangle of type int. So that's the reason that I need to go back here and change this to float, change this to float, like so, and then we will see that it should stop complaining, hopefully. Okay, so as we can see, we still have our ball, it's still not moving. Xcode is being funny. Yeah, sometimes it shows the errors when they're not actually there anymore. So now what we need to do is we need to move this across, right? So what I could do is I could say, well, let's just make float, let's just say speed x, and then we will set that with a value of 1 to start off with. And then what I can do is I can just say, I will do it down here just so we have a logical kind of storyline, so to speak. So we could say pos x. So I'll show you the long way and then I'll show you the short way. So we got pos x equals pos x plus speed x, right? So that's one way we could write it. We could also write it like this. Okay, if we want to shorten it down a little bit, we could do pos x plus equals speed x, and that means the same thing. Okay, so once again, I will hit play, and we will see that it's still not moving, right? Still not doing anything, even though we've called for the position of x to add every time it calls this paint method, it should add the speed of x to pos x, which is 1, and it's still not doing it. Well, why is that happening? The reason it's happening is because we haven't called repaint. So this is the whole purpose, going back to our timer callback. The timer callback is getting called 60 times a second. And what we could do now is we can actually say ball.repaint. And what that does is that actually calls the paint method over and over again on our ball object. And we will see that now the ball is moving across the screen, right? So I will do that really quickly again. Drag it over. We see that the ball is moving over. So great. So that's fine, right? So now let's make this a little bit more complicated. And let's say, okay, well, the ball disappears because it's always going positive in the x direction. So what if we want it to bounce back, right? So we will do this piece by piece, and then we'll optimize a little bit afterwards. Okay, so we got if pos x, or if pos x is greater than or equal to get width, then we should do speed x equals minus speed x. Okay, so then what that does is it just changes it back to it just flips it around so that we are actually going back in the other direction, hopefully. Okay, unless my math is wrong. So we got this, and we see that it bounces back, okay? And then it disappears. Okay, well, we saw that, so we observed a couple things here. We observed that the ball actually kind of went all the way off the screen. It didn't bounce like a real ball should bounce on the screen. And that's the reason. The reason for that is that when we create this rectangle area here, we have pos x and pos y, which are 10, 10, and that's starting from the top left-hand corner of the ball. Okay, so that's starting from the top left-hand corner of the ball. So what we need to do is we can create a variable. So rather than putting 20, so our ball size is 20, right? So rather than saying get width minus 20, and then we have 20, and we have 20 again, what we could do is we can actually create another variable. So we got float, we'll just call this size, and we will say that it's 20, okay? And this is something that when we find ourselves kind of repeating the same number, repeating the same thing over and over again, and referring to the same thing, it's better for us to have this in one place, so that if we wanted to change the size of the ball, and if we just had 20 everywhere, then we'd have to change 20 a million times. Everywhere we put 20, we would have to go back and change it. But since we've only got one variable called size, then what we're doing there is we're just saying, hey, we just change this one number. We can change it to 10, or we can change it to 50 or a million, and it will change everywhere that we have this. So we got pos x is greater than or equal to get width minus size, right? And what we should see here is that this should go to the edge, and boom, you see that it bounces like a regular object, right? And then it disappears off the screen. So now we need logic for that, so we can use or pos x is less than or equal to 0, because we're already on the left hand. Like I said, the position of the ball is from the top left hand side, so it will be when the ball gets left hand side of the ball gets to position 0 of the width, then that's really actually 0. So we don't have to do any sort of offset or anything like we did for when it got to the right hand side. So now we will see that it goes to the left, or to the right rather, and then to the left, and now we will be infinitely going between 0, and get width. Great. Okay, so let's do this for the same thing in the y direction, right? So we could say float speed y, and then I'll say let's just make it a different number, 3, and then we will just do this. We will do the same thing, plus equals speed y. And then we just need to do the same thing, same sort of logic. So if pos y is greater than or equal to get height, because we're going in the y direction, minus the size, or pos y is less than or equal to 0, and then we got speed y equals negative speed y. And so now we should get a ball that's going, and now we see that it's going all over the place now, right? So now we have this repainting the way that we want to and everything, but following Chris's advice, we need to take all of this logic and we need to now bring it over into our timer component. Okay, because there are a couple of reasons. Well, one reason is that because the paint, so this is something I know a bit about, I'm not an expert on, but the repaint calling only gets called, it doesn't get called every time this timer callback gets called, because repaint, so that's because our graphics is kind of secondary to what our audio is doing. Okay, so it's not on a high priority thread. So our audio callback, if we had audio, that would be happening on what's called a high priority thread. What that means is that no matter what, the audio callback has to get called. Okay, but the graphics callback does not get called every time, so to speak. So what that means is that sometimes this timer callback may actually get called, but repaint does not actually happen until it's kind of convenient for it to happen within the thread system. Okay, so what that means is that, and that along with the problem I described for you earlier, where we have the if we were running in a plugin rather than an audio app, where we have a window that's opening and closing, or even if in here we had like this window and the window opened and the window closed, what would happen is that if we killed off the window, so when we close the window, then this logic that we have in here in the paint method, that doesn't exist anymore, so to speak. And so if we have some sort of LFO or something that's some sort of sound that this circle is supposed to be representing, that's supposed to be moving, so if that component doesn't exist anymore, or it's not getting called anymore, then this logic isn't happening. So what would happen is that the audio would just not move the way that it's supposed to. So now we need to take all of this and we need to actually move it to our timer. So we're just going to cut this, and we're just going to add a couple lines of space here. I'm just going to paste this in for now. So, and I will just point out a little principle here. So as you can see, in the class that I created of ball, I actually have these variables, the pos x, pos y, so on and so forth. These are actually in our public, declared as public. So public means that we can actually access these variables from another class. Okay, so what we need to do is we need to actually go in here, and we will see that it doesn't recognize in our main component, because we moved this to a different class. We've moved this to a different class now, and it's saying pos x. I don't know what you mean by pos x. Okay, but you remember that we created this object called ball, and what we need to do now is we need to say, hey, we're talking about ball, the ball pos x, and the ball speed x. So you got ball.pos x, ball.speed x, and we will just do this for all of these, right? Okay, and now we get to a tricky one that's easy to overlook. Get width actually needs to be ball.getWidth because we are talking about the actual dimensions of the ball component, not the dimensions of the component that we're in now. Okay, so we got ball.size. .speedx, and then ball. So all of these. Okay, and now this should compile for us, should work. And we see that it works just the same, but now we've kind of optimized this so that this will be calling all the time, no matter if this window is open or closed or whatever. So that's it. So that's the tutorial on repainting components using the timer class. And that's the end of the tutorial. So I hope you enjoyed this and found this useful, and I will see you next time.